session with us, we've got Professor Chon from Chulalongkorn University. We have Dr. N. Sitrop from NASA, and also Alison Craddock from the IGS, also from NASA. So given that we are running a little bit behind schedule, and I'm sure many of you want to catch up on your coffee at 3 o'clock so that we can resume the afternoon session at 3:15. So perhaps, again, we'll try to do our best to finish maybe, say, 5 minutes past 3, give people some time for coffee before the next session. So before I hand over the microphone to our presenter, so this session is GNSS, is on GNSS reference system, and you will hear from our presenter today as to why reference system is important, right? So many of us, we are familiar with coordinates. We know coordinates are a set of numerical values or alphabet. Now, have you ever thought, how did those numerical values come about? How are they derived from? So this is my first trip to Chiang Rai. I haven't had the opportunity to visit, the city center. And like many of you in the audience, I imagine it's also your first trip to Chiang Rai. So like me, I'm very keen to go down to the city center after the session today to get some massage and maybe dinner. But because it's my first time and I don't speak Thai, there's some language barrier. I tried to get direction to go down to the city center. And imagine this person, I asked the person for direction, well, how do I get to the city center from the university? And the direction that was given to me was, well, okay, you leave the university, you turn left, go on this main road. Okay, go on this main road for about 20 minutes. You pass the airport on the left. You'll see the airport on the left. You go on for another few more minutes. You cross the river. I was like, okay, you cross the river. And then about 1 kilometer, you should be able to see the clock tower in the city center. And I've heard a lot about the clock tower in the city center. But what I did not know is there's actually 2 clock towers in the city center. There's the old and the new one. So like me, if it's your first time and the person giving me the direction had directed me to the old clock tower, then I did not get to see the new clock tower, which is about 500 meters, as I understand, further south, heads towards south. So this is very similar with reference frame and coordinate. Imagine you're relying on your blue dot on your phone and getting from A to B, and the reference, the direction of that blue dot is different because there's 2 different reference points. You'll end up to a different location altogether. So hopefully that gives you some context around the conversation that we are going to have today. So on this note, I'm going to pass my microphone now to our first presenter, Professor Chon.
Can you turn on my slide, please? Okay. Thank you very much. And thanks, Julin, for the short introduction of how important the reference frame is. And this talk is not anymore a kind of research work, but it's a kind of work that we have to do in terms of the maintaining of the accurate reference frame of our nation. So this is a kind of our experience and also some of the update information that as a university we are working or collaborating with the practical agency, which is a national mapping agency in Thailand, whereby we try to update our reference frame to be the latest and most accurate one. So my slide is intended to show you why and how we have to do this kind of work. So the topic of my presentation is to the unification of the GNSS core in Thailand and update this kind of coordinate set to the ITIF 2014. Thank you very much. It doesn't work. have to turn it on. No battery. Okay, thank you. But I still cannot see it on my screen here. Oh. Okay, just I have to. Okay, this slide is just to show you the example of why we have to do the update of our reference frame. From the past, we have a very big earthquake in 2004, Sumatra Andaman earthquake. After that, we did some observation with the GPS campaign right after the earthquake every 6 months in order to update our reference frame to the latest one. During that time in year 2005, it's quite difficult because that time we didn't have a GNSS call station. So most of the observation come from the campaign mode, whereby we have to carry our receiver and put it on the point. We have around 7 zero order network in Thailand. So every time we want to redefine our reference frame, we have to do some observation at around 7 days. So the officer from Royal Thai Survey Department usually do that every year. Right after the earthquake, we keep monitoring the effect of the post-seismic deformation from the Sumatra Andaman earthquake. And then we started to show the coordinate set and map ourselves to ITIF 2005 by using the data in year 2008. I have to separate between the reference frame, which is the name of International Terrestrial Reference Frame, so-called ITRF, followed by the year that was released. For example, in this case, we would like to map ourselves to ITRF 2005, but the data we used was observed in year 2008. So we usually refer to the time at the epoch whereby we observe the data. So in this kind of sense, it means that the coordinate is moving with time. So we have to fix at a certain epoch of the time in order to make sure that people don't get confused and we can do the transformation between the epoch. In this case, Royal Thai Survey Department make an update to the reference frame to ITIF 2005, whereby other agencies in Thailand, for example, Department of Lands, Department of Forestry, and other agencies do not know that and still using the old coordinate system. This comes to a confusion between the government agencies. And this kind of confusion making a lot of waste of money because they have to create a project whereby they call one map policy, whereby they want to combine all the boundary or the points from every agency. But each agency are using a different reference frame. So up to now, we have established what we call the National Core Data Center, whereby we combine all the GNSS calls around Thailand. Right now, we have almost 300 stations around Thailand. So I'm seeing this as an opportunity of Thailand that we can make use of existing GNSS core data to update our reference frame to the most recent one and make it as accurate as possible. You can see the example on this slide that we can see the difference between different frame at different year and the difference can be up to decimeter level and some area even up to meter level in some cases. This is due to the post-seismic motion of the large earthquake as well as a plate motion in this area. So this is just a definition of how we create the ITIF, whereby we combine different space technique, for example, GNSS, VLBI, DOLIS, or I think someone, okay, SLR or LLR. We can see the different version of ITIF that released in each version, and up to now the latest one is ITIF 2020. But at the time we try to update our reference frame. We tried to do it 2 years ago. That's why we didn't make use of ITIF 2020. That's why we have to stick with the ITIF 2014. But somehow we believe that our reference frame could be accurate at millimeter level with the good processing and also good enough data to do the processing. In Thailand, in the past, we were using a lot of local datum. In Thailand, we usually use the datum Indian 1975 up to around 15 years ago. Then we decided to move to WGS 84. That most of the people understand that, but WGS 84 in this sense actually processed by Royal Thai Survey Department. Actually, they actually mapped themselves to ITIF, but projected the coordinate into the geographic coordinate system like a latitude, longitude, and height above or below ellipsoids. So we calculate all the transformation parameter between the local datum and the global datum to the ITIF. And up to now, we see that different agencies make use of different coordinate system, and it's come to a very big confusion between agencies. Just on this slide, example is that Royal Thai Survey Department already make an announcement to use the ITIF 2008 by using the data observed in the end of 2013, whereby Department of Land still using ITF 2005 with the coordinate set at the epoch of 2008. So this kind of difference come to decimeter level of difference. That's why we think that once we have a core station, we should be able to calculate the reference frame and make a transformation parameter between the different epoch much more easier than in the past. So the computation is based on the use of Gypsy X software. Thus we have to thanks to JPL to provide us the license of the software without any charges. So we did all the calculation of the station in Thailand up to around 250 stations at the same time with the data of 1 week approximately to come up with the unique coordinate set at different epoch. The first two columns is ITIF 2005 and ITIF 2008, but the final one is ITIF 2014 with the data we used at the end of year 2021. So this, we believe that by updating to this coordinate set would be the most updated one and most accurate one to be used and to be shared among the government agency, and we can avoid a lot of confusion by using the different reference frame. So this has been officially announced by Royal Thai Survey Department, and I believe most of government agencies are now agree with this kind of idea and would like to come to use the same coordinate set of all the core station. So I see this kind of thing as an opportunity for Thailand that once we have a national core data center, we can use the core station to be replaced for the survey mark in the past and update ourselves to the most accurate coordinate system. This is what I would like to share and try to tell the story that how we update ourselves to the latest coordinate system. After, after this is more on the calculation of the transformation parameter between the different ITIF in Thailand. So it's not really the main or the key message that I would like to say. But right now, officially, Royal Thai Survey Department make an announcement on the website to use the ITF 2014 at the epoch of 2021, around the end of the year 2021. So all the government agency in Thailand are now will now follow this kind of coordinate set and make use of it. And we believe this kind of coordinate sets will be accurate at millimeter level in Thailand, all over Thailand. That's all. Thank you.
Any quick question for Professor Chon, because he might not be able to stay to the end of the session because Professor Chon is chairing the next session. But if there's, is there any questions from the audience? Maybe if you could come out and use the microphone.
Hello, my name is Renjie and I'm from Entity Data. And I have basically two questions for your presentation. The first one is you mentioned that different agencies are using different data. For example, the first one used 2013, the second one used 2008. I want to know why they use different years of data or why there's a gap between them, and I want to know how's the situation now with the improvement.
Yeah, because the main problem is that in the past, when we would like to update our coordinate system for each agency, we have to rely on our data. And usually we have our survey mark around the country. For example, Department of Land established maybe 3,000 survey marks around the country. They make some observation and try to connect them to the network of RTSD. So in order to update the coordinate system, they need to do some observation in the field work in order to link their network to RTSD network and adjust their network to be able to map their coordinate to the RTSD. That's why they need some time to work on that. For example, RTSD announced ITIF 2005 in year 2008. It requires about 2 or 3 years time that Department of Land has to do observation, do all the calculation, and make an announcement. When they make an announcement, by that time, RTSD already make another announcement to the new ITIF. So it requires some time to catch up. But right now, all the department sharing the GNSS core data. Department of Land has 180 stations, RTSD have 80 stations, and other member. We combine all the stations into one single server. So right now, it's become much more easier to update ourselves to the new coordinate system by using the data, the same data set. So that's how the situation at the moment is like. Yeah.
All right. Thank you. That was an excellent question. But I guess in the interest of time, maybe we should progress along the presentation. So our next presenter is Ant. So Ant, you're a senior researcher at JPL NASA, and Ant specializes in satellite geodesy. So we heard from Professor Chon earlier that the core station are your reference point. But I guess, and your reference point are essentially the satellite up in space that provides you with that reference point. So over to you, Anne.
Thank you, Sulin. Thanks to the sponsors and the organisers of MGA for inviting me. It's very nice to be here with you guys and have the opportunity to present some of the work that we've done at JPL. I'm not going to talk in depth about reference frames, but I do cover it. But we're going to cover a large number of topics. So let's jump into the presentation if we could. Okay, there we go. That's great. I can see what I'm doing. Okay, so I'm going to be talking about both our post-processed and our real-time orbit determination and point positioning services. And for many, many years we were very focused on GPS only, and we've slowly come into the present day. Now we're starting to use a lot more multi-GNSS data, and we have an analysis center as part of the IGS, and obviously JPL staffs and funds the central bureau of the IGS, and we also have a real-time operations system called GDGPS, which originally focused just on GPS technology, but is also now multi-GNSS capable. So a quick outline. I'm going to give you a brief outline of my background. I'm going to talk a little bit about the origins of Gypsy X and where we are now. Talk a little bit about our analysis center and real-time systems, and then look at some case studies of precise orbit determination and point positioning, reference frames and applications using multi-GNSS. So I was originally a field archaeologist for about 10 years, and I worked in the UK and Germany and Italy. I worked in Pompeii for about 6 months. And part of that is planning. We draw detailed plans of where things were on the archaeological site themselves, and then we would want to tie those plans into the national mapping system. In the UK, for example, it was the Ordnance Survey. And how would we do that? Well, often we'd set up control networks at some point we started using GPS, and that got me interested in land survey. And I did a master's in surveying part-time while I was working as an archaeologist in surveying. When I finished that, I started a PhD, and that's in satellite positioning and specifically astrodynamics, mostly radiation pressure force modeling. And when I finished my PhD, I started a postdoc at University College London. And you might notice on the side of the screen here, the young lady in the pink t-shirt is Thailand's own Queen of Time Synchronization, Thaya Tip Tongtan, right here. In 2008, I moved to the Jet Propulsion Laboratory, and since I started there, I've been a Gypsy developer and started work right from the beginning on the next generation Gypsy X software. And my main responsibilities in that group now are trying to make that our operations software, so a lot of scripts that wrap GPCX, work with multi-GNSS. The GPCX itself is fully multi-GNSS capable, but we have to collect data, aggregate it, and shuffle it around. So it's that kind of stuff that we're doing. But I'm also part of the real-time service, and I also am the flight software lead for the Cold Atom Lab on the International Space Station. So a little bit about the heritage of JPL's background in GNSS, GPS data processing. It started with Gypsy, which was a Fortran, Perl, C, Seashell mass in the very early days of GPS. Started, in the late 1970s, early 1980s, pretty much. Went through for a long time. It was powering our operations for GPS and our IGS submissions until something like 2017, until we finally retired it. At the same time, GDGPS, as a spin-off, wrote its own software, RTG, which is real-time Gypsy. That was written in C, and it took certain liabilities with taking out some capabilities just to make it run faster for real-time processing. And then in about 2009, 2010, with funding from the government for GPS operational control segment, OCX, the next generation, we started writing GPCX. And RTGX is the central component of that software suite. It also has terrestrial reference frame capabilities, and so RTGX plus those reference frame capabilities, which is a suite of tools for manipulating station time series, we call GPCX. So as part of the IGS Analysis Center, we've been making orbit and clock products for about just over 30 years, in fact. We were one of the original few analysis centers. We produced a suite of post-processed orbit and clock products every day. We have a very low latency hourly product called Ultras. We have a daily latency product called Rapids, and a weekly product called Finals, which is our highest precision set of products. We serve an international community of scientists. Some of those products are mostly for our internal use at JPL, for our DSN operations, Deep Space Network. And a lot of those we're starting to convert to GPS plus Galileo, or they're certainly available alongside our GPS-only products at the moment. And as Professor Chon was saying, the GPCX processing software is licensable, and you're welcome to investigate the link here, and hopefully these presentations will be made available to you. This is a little bit of the history of the IGS. You can see that over time, of course, things have gotten much better, which means there's a significantly greater agreement between each analysis center. And the three arrows that point down highlight some of the times when we've departed from the other analysis centers. And part of that is because we have to stick to reference frames to support space missions, because they don't like jumps in time series, which is exactly what you can get if you switch reference frame. But as soon as we did a full reprocessing of those orbits and clocks in the next generation time series at each of these arrows, you can see we hopped back down to the other analysis centers. And the last one on the right hand side here, where we pop up, is because we're still in IGS 14 and everyone else has moved to 20. But later this year, in the next couple of months, we'll also reprocess in 20 and everything should come simpatico again. So the GDGPS which is perhaps a bad name, but maybe we can think of it as the Global Differential GNSS Processing System, is focused fully on real-time orbit and clock products. It's been operational since about 2000, and it has, for a number of years, actually been processing data from not only the 4 main global satellite systems, but also systems like QZSS and NAVIC. It was originally supporting international telecommunications, so broadcast corrections that telecommunications providers would send to people's phones for better positioning on the ground, but also agriculture and shipping. We also provide independent monitoring of the GPS constellation and others to Space Force, and this, as well as our IGS operations, are now fully powered by the GPSX software. So for precise multi-GNSS orbit determination, I mentioned this a little earlier, we have GPS-only hourly, daily, and weekly products available. We have a JPL format, but we also convert those to IGS formats, which are used by different software suites. We also are now making GPS plus Galileo products available to the public. They're currently only in our own internal format, which you can read with GPSX. But we hope that in the next couple of years we'll start making these available as multi-GNSS products. So real time, in post-process we're down to the sort of 2 centimeter level accuracy. In real time it's a little bit worse, but it's not that much worse. It's 5 to 10 centimeters accuracy. We pull in data from stations around the world, not only the IGS, but our own series of ground stations and those from NASA. And we're always looking for collaboration with other people who might want to provide data to us. So if you have have a way of providing data to us, feel free to talk to me if you'd like to be included. There are also some RTCM and SSR streams that I don't think they're available at these links yet, but they will be coming available later this year. So this is my main slide about the importance of reference frames. So it's a little bit complicated, but any solution prefixed with an M underscore is a multi-GNSS precise orbit and clock solution, and if it's prefixed with G, it's GPS only. So we can see in IGB 14 we've got both multi-GNSS and GPS only orbits and clocks, and then from those, in the parentheses after it, we also do either GPS only or GPS plus Galileo precise point positioning to see how well we can recover the reference frame. And over time, of course, as Professor John highlighted, reference frames have typically gotten much closer together. So there was a big jump from 2005 to 2008, slightly smaller jump from 2008 to 14, and an even smaller jump from 14 to 20. But it's always important to keep up because the reference frame degrades over time. But you can see here, it's showing, so it's a cumulative distribution plot, so the trace that climbs the fastest is the best. And we can see that the traces on this side of the plot are the traces using both multi-GNSS precise orbit determination and multi-GNSS precise point positioning. And the ones that do worst are in 14, those same sets of orbits and clocks. So this was a problem with antenna calibration for the Galileo satellites that were not consistent with GPS satellites in the IGB 14 frame. And it's, we had the ground measurements for the Galileo antennas, but they can't put the entire spacecraft in the anechoic chamber to measure them. So it's a great start, but when you get down to the precise level, you can see differences. And you know, we're looking at changes from sort of 7 millimeters down to 3 to 4 millimeters, and it's horizontal and vertical precision in these two plots. So this is just a quick demonstration of how we do in real time. So you can see the traces here. The scale on the y-axis is in centimeters, and this is fully kinematic positioning. We're processing GPS and Galileo data. It's pulling in data from 206 stations, and this is one of them. And we do pretty well. You know, it's at the 1 to 2 centimeter level, and we can use that as we see here. So this was a recent earthquake on Davao, on the island of Mindanao in the Philippines. We captured the earthquake highlighted by the dashed vertical line pretty rapidly in real time. And on the bottom, this is a new capability where we're looking at atmospheric tech recovery from GNSS processing. And this uses a lot of data. I think we can see, well, if the screen was higher resolution, we could see that this is GPS, Galileo, and Beidou data that's gone into the tech plot on the bottom there. Thank you. This is the same thing for the 1st of January earthquake on the Noto Peninsula in Japan. And again, on the left side, we can see our real-time precise point positioning from GDGPS, and on the right, the Guardian system. And these links are publicly available. You can go and poke around Great Alert and Guardian and look for yourselves at what it can do for you. And here we're obviously processing Galileo, GPS, and Beidou and GLONASS to get these tech results. We also are going to be introducing in a not quite certain amount of time a high accuracy service from GDGPS. For GPS in particular, there is no capacity in the signal in space message to transmit this system, unlike Galileo, which will broadcast it to you. So we have to rely on distribution over internet and landlines. But we can see here that we meet and exceed the accuracy requirements set for phase 2 of Galileo HARS, and we beat them at their own game basically. We're the yellow, and the Galileo HARS is in green. And this is, so we produce a set of corrections, and they're independently processed using a PPP engine from York University of Canada. So we tried to divorce our processing system from the generation of the corrections. And that's it. I'd like to thank you very much, and my colleagues for their contributions to this presentation.
I didn't manage to keep my promise. It's already 4 minutes past 3. So I apologize. No. Blame the previous session, Chair. So maybe we will hold off questions for now and go to Alison's presentation, and then perhaps we'll move the Q&A perhaps to coffee, just so we'll make sure that the afternoon session will start on time. So on this note, while Alison get ready with her presentation, just a quick, I guess, introduction of Alison. Alison is the director of the International GNSS Service, or the IGS, which you've heard from Anne's presentation. You've also heard from John around some of the challenges in terms of, different calls, infrastructure, and as a result of that, difference reference system. And the effort for the IGS is really to try to bring everyone together, share data, and you've seen from Anne's presentation the importance of having access to information or data set in order to make sure that we have a consistent reference frame, as we could see in the ITRF. So on this note then, Alison, over to you when you're ready.
Yeah, I don't think I can share from
Yep, they will share it from their end. Yeah.
Okay. Oh, excellent, excellent. Desktop one, okay, share. Oh, well, they've got a. Okay, sorry. All right. Just close this out here. All right, everybody. Well, I hesitate to be the person who stands between everyone and a fantastic coffee break, but I will say that, hearing all these things, one of the important things is that we all work together. We work across boundaries, across continents, across time zones, cultures, and languages. And this is because to do this work, we all know that we need to collaborate. It's not optional. And so I will try very quickly to go forward and bring you a little bit of an introduction to the IGS, and most importantly, an invitation, a welcome to come and join us and participate in whichever way you see fit. Everyone here has something that they're doing for geodesy and in GNSS that is important, and that sharing it can help us all move forward and make the best use of these assets. So the IGS has been providing openly available GNSS data since 1994 officially. We are now officially 30 years old, which is putting it into a bit of harsh context for those of us who remember 1994. We are one of the services of the IAG. The earlier presentations noted that the reference frames are not just GNSS. We really need the support from our colleagues in VLBI and satellite laser ranging and DORIS. And so we all work together within the International Association of Geodesy. As Sulin already introduced, and as some of our earlier presentations already alluded to, the IGS is a voluntary federation of agencies, research institutions, and all collaborating to make high quality and openly accessible GNSS data and services. Sorry. Our mission is to provide these high quality GNSS to everyone all over the world on a free and openly available basis, and to also support PNT as well as the formulation of reference frames. So like I said, we turned 30 this year, and so we had a bit of a reflection on our 30th anniversary. We grew and evolved as a dynamic and important global collaborative platform that we leveraged the collective contributions of our diverse members from all around the world. And that now we're not only technically involved in technical innovations, but also trying to be a catalyst to scientific advancements. We saw a lot of the things in earlier sessions about all these new applications of GNSS that are being brainstormed and developed. And that this is something that the IGS strives to continue to support and nurture. So we try to enable global collaboration for unparalleled scientific benefits. And we do this through our global network of GNSS ground stations. We have over 510 in over 100 countries and regions. I encourage you, throughout my presentation, I do have some QR codes and links to our IGS website. In the interest of time, I might go a bit quicker. But I assure you, everything that I'm about to present, you can find on our IGS website. So I would encourage you, please visit it. And if you have any questions or anything like that, please find me in the coffee break later on. So what are our products? We collect, archive, and distribute all these high-quality GNSS-based data sets to satisfy a wide variety of objectives and scientific needs. These are, as we said, really diverse community benefits, all from underpinning Earth observations to national reference frames, positioning, navigation, and timing, and this ever-growing wonderful use of GNSS in science. And one of the things that we do to make sure that that's possible is to support developing data standards to improve the service quality and advance theory. And one of those things is the RINEX standard. Again, there are so many scientific insights that have been brought forward by IGS work. For example, crustal movements, geospatial information management, our colleagues in the surveying industry, and more recently, understanding the atmosphere. There's a lot of things that the atmospheric, what we used to call noise, has now been discovered to be actually a really interesting signal. We see it now informing things like GNSS and enhanced tsunami early warning systems. So we never really know where the next innovation is coming from, and we can only really find that innovation when we talk with each other, when we come here together and we have a coffee and sit down and just brainstorm. And so, as my colleagues already noted, we try to connect the world with the ITRF. GNSS data really is the gateway for everyone who needs to use the ITRF, the International Terrestrial Reference Frame. And I won't need to go into it because it's already been explained so beautifully earlier, but it is an accurate and standard frame for referencing positions at different times and on different locations in the world. And it provides a really important foundation for nearly all applications of Earth system science and observations. We do have a new reference frame combination center website. I encourage you to visit it. It was developed by our colleagues at IGN in France. The website is up there. And so we try to enable innovation and adaptability. One of the ways we do this is through policy and leadership. We're always advocating for the value of open access and sharing, data sharing, knowledge sharing, resource sharing, that we see time and time again. The more that we share with each other, the more that we communicate with each other, everyone benefits. And as such, hopefully we are seen as a positive community resource. On top of that, recently the United Nations has also started getting interested in helping geodesy and advocating for the value of geodesy. There are two entities that I would like to draw to your attention today that are doing this in a very strong and united way. One is the United Nations Office for Outer Space Affairs and their International Committee on GNSS. And the second would be the United Nations Committee of Experts on Global Geospatial Information Management. And through that is the Subcommittee on Geodesy, and also now a brand new Global Geodetic Center of Excellence in Bonn. If you have not heard about that, I would encourage you to please look it up, Google it. They are having listening sessions. They want to hear from everyone around the world. So you are most welcome to provide feedback to any of these UN entities, or you can talk to the IGS, and we'll be very happy to relay your concerns, your needs, your observations, because everyone's voice needs to be heard. We don't know where the next great observation, the next great breakthrough is going to come from, but we do know that when we talk to each other, when we share our thoughts and our information, that everyone moves forward and benefits from that. And on top of that, some of our colleagues in the previous session were talking a little bit about the Sendai Framework for Disaster Risk Reduction and the Sustainable Development Goals. And we try to, just as the terrestrial reference frame translates our positions, we try to translate what we do and the value of GNSS in the language of policy, and say, well, GNSS contributes to Sustainable Development Goals. How? And how can we use this as a way to share this information and inform policymakers who make decisions? So we have a number of components. I already touched on our ground station network, but we also have data and analysis centers, working groups, as well as the governance elements of our organization, and most importantly, the associate members. These are people, just like many of you, who have decided to join and become members of the IGS. I would encourage all of you, if you're interested, I'll show a little bit later the the link to apply to become an associate member. It's open to everyone. It costs nothing except a little bit of time. And we very much so would like to make sure that everyone feels that they have an opportunity to come join in the work of IGS. I will just skip over some of this stuff. We have a brand new IGS Analysis Center. Our colleagues in Japan at JAXA and GSI joined forces, and in just a couple of months ago, our governing board approved a new IGS Analysis Center. So very proud of that, and looking forward to working with them. As Ant already talked about, individual analysis centers do provide important perspective. We have a number of committees and working groups. This is me inviting every one of you, if you are interested in any of these committees or working groups, please reach out to us. Contact the Central Bureau of the IGS to come talk to me. Look us up on the website. These are always open. You're always welcome to come in and start talking with some of the people in the working groups. Some of them don't meet as often as others, but if you're interested, you're welcome, and please do consider joining up if you'd like to learn more. And how do you find out about the people in our working groups? You can come to some of our events. Not all of them are in person. We have, through the magic of the pandemic situation, discovered that we can set up a lot of our meetings to be inclusive to our all virtual environment. And we actually had some mini workshops. I would encourage you, this is the link to our YouTube page. Please visit them. You're welcome to learn more about this. We have a lot of people from our community who prepared a lot of great presentations. We will also be celebrating our 30th anniversary with a community workshop and symposium this year. It's going to be in July in Bern, Switzerland, a beautiful spot in the Alps. So please do consider coming. You're most welcome. And I'm going to kind of move forward a little bit more. Yes, participate. Participate, participate, participate. Please join our mailing lists if nothing else. I promise it's not spam. And it's a great way to be informed about all the things that the IGS is doing, opportunities for participating, and it's how you learn more about what we can do, how we can share, how you can benefit. As I said, you're welcome to become an associate member. Please, this is how you apply. And if your organization is already involved in the IGS, we have a great new part of our website all about celebrating the individual contributions of our contributing organizations. There's a form at the bottom of the page. Please, if your organization is involved in IGS and it's not featured on this page, please fill out the form, and we would love to feature your logo and whatever information you would like on this page in order to be able to appropriately acknowledge all the things that all these organizations are contributing to us. And I think I'm getting towards the end. So we have new guidelines for ground stations. This is a great new resource that our infrastructure committee has put together. If you are at all curious about how IGS ground stations are qualified, how to build one, who to come to if you have any questions, please check this out. And finally, supporting each other. We have a number of social media resources. You're encouraged to find us on LinkedIn, join the IGS virtually. We have lots of announcements on there and all sorts of interesting tidbits and news pieces in between. We're also on X, the YouTube page, and that's it. Coffee time.
So thank you, Alison. Indeed, time's up. But look, I've just been told that we'll have a short 5 minutes coffee break before we start the next session again at say 3:25 to 3:30. But most of us will be around tomorrow as well if you want to catch any one of us up for questions or comment. But the takeaway message today is all about reference frames, the importance of reference frame. why and how I could see the clock tower later today, the importance of having a consistent reference frame. So let's talk more about reference frame today and tomorrow. And once again, another round of applause to our presenter again. And thank you.